Thanks to you all. My name is Keneilwe Molapo, and today I'm going to teach you a topic about equilibrium of a particle. So firstly, you have to know what equilibrium of a particle is. Equilibrium of a particle occurs when two forces acting on that particle balance each other so that the particle remain at rest or move with a constant velocity. So I will be making one example or two. So when we have when we have a when we have a let me give you an example with a bench that goes down. So our particle here, it's this again. So the two forces balancing each other is this one and this one. They balance each other so that this particle, this force, this one can do what? Can remain at rest or move with a constant velocity. So another example is when we have a weight going down, then this weight is balanced by this force and the other force. So this is a weight going down. Again, this weight is balanced by what? This weight is balanced by these two forces. These two forces, they balance this weight so that this weight can remain at rest or move with a constant velocity. So that's what we call equilibrium of a particle. We also have two conditions, not two, we also have conditions of equilibrium. Again, the conditions of equilibrium are horizontal components and vertical components. So you know your Cartesian, if you know your Cartesian very well, Cartesian plane, let me draw. You have a Cartesian plane here. This is your y values, this is your x values. So you have to know that your horizontal components are your horizontal components are your x's, then your vertical components are your y. So what you have to know about these conditions is that sum of the horizontal components must be equals to 0. Sum of horizontal components must be equals to 0, and sum of vertical components must be equals to 0. That's what you need to know. Another thing that you need to know is your SOHCAHTOA. You have to know your SOHCAHTOA very well. So we have our SOHCAHTOA. So with your SOHCAHTOA, let me just do it like this. With your SOHCAHTOA again, you have to know that your S stands for sine, your O stands for opposite, your H stands for hypotenuse, and you also have to know how these things are on a triangle so that you can know if you are using sine, cos, or tan. So let me draw a triangle for you so that I can explain to you so that you can understand. So we have a triangle like this. Then we have an angle of 90. We have an angle here, maybe it's 50 degrees, for example. It is 50 degrees. Okay. Then after having this angle, you must know that always the line opposite your right angle is your what? Your hypotenuse. Then you also have to know that, let me change colors. You also have to know that the line opposite the angle, it's opposite because what? It is opposite your angle. Another thing you have to know is that this is your adjacent. Even if, let me draw another triangle so that you can see what I'm talking about. Then you have your angle here, have maybe let's say 60 here. Then always know that this is your hypotenuse. Always know that this is your opposite, because it is the line opposite the angle inside that triangle is your opposite. Do you understand me? Then you know that this is your adjacent. So can you see what I'm talking about? How you see these things. So now we are coming to our soccer 2 again. So we have a sine, which is so opposite over hypotenuse, sine, cos adjacent over hypotenuse, then tan, which is adjacent over opposite. So you can see that these things, I've put them according to how they are here. Like sine, okay, let me use another color. Sine is your what? Your opposite over what? Over hypotenuse. Your opposite over what? Over your hypotenuse. Then cos, it's your what? It's your adjacent. This adjacent over what? Over hypotenuse. Then your tan, it's your what? It's your opposite over what? Over adjacent. So now, since you know your soccer 2 very well, I have problems that I want to solve with you. So let's start with our number 1. Let me erase this for you so that we can start very well. So for our number 1, okay, sorry for not erasing that. So here, I think you can see clearly. Here on our number 1, they say the crate has a weight of 550 N. Determine the force in each supporting cable. So now, since they say determine the force in each supporting cable, you know that the forces that they're talking about is this one and this one. Again, they support this one. So firstly, we have to know that, okay, let me draw our free body diagram so that you can understand. So firstly, we have to draw our free body diagram for number 1. Let me use another color for free body. Okay, so our free body diagram will be like this. This will be our weight going down. This is our weight, which is this will be our weight going down, which is our FAD. So let's write FAD here. FAD. Then we have, let me erase this so that you can all see. We have our C, which is going up, right? This one. This will be our FAC because of this line. FAC, our force AC. Then we have another one going there, which is our force AB. FAB. So this is our weight, this is our force applied, then this is our tension. So now, since we have drawn our free body diagram, we need to start calculating our diagram so that we can get the forces that they are looking for. So now let me erase this. This is for when I was explaining. Okay, let me use another color so that we can. Okay, now we will start with B. Let me say at B. Let me say at B. At B. Okay, so at B, so we go back, we look to our, we look at our diagram here. Okay, the diagram that we have. So at B, we will draw this triangle, this one, so that we can all understand. Okay, so okay, let me write it here so that when we go back, we can go back to it. So okay, at B, at B we will have a triangle like, let me draw using another color. At B we will have a triangle like this, and like this. No. At B we will be having a triangle like this. I get it, it is going like this. Then yaba B A. Then yaba then we also have an angle here, which is an angle of 30 degrees. So here at B, we will be looking for our horizontal components and our vertical components. So for our horizontal components, we will say horizontal components equals to, you can see that this is going that side, which will be negative F A B. I agree, we will be using this one, the A and the B. So we will be having its horizontal for this triangle, which is FAB, the cos of 30 degrees. Then for our vertical components, which is equals to FAB, since it is going up, it will be positive, the sine of 30 degrees. So now we'll be looking at the other side for our, let me go back to the diagram. So this side for, okay, let me erase this. We will draw this triangle like this. So we will draw it aside so that we can all understand, and also draw the inside triangle for C. At C, let me draw the triangle. At C, we will be having a triangle like this. Sorry. At C, we will be having a triangle like this, Then this is our C, this is our A. Then we have our so we have a smaller angle here, which is 5, sorry, 5. Let me start again. So at C, we have our triangle like this. Again, our triangle like this. Our triangle like this. Okay. And then we have another. Then this is C. This is A. Then this. This goes this side and up. Then they meet here at C. So here here we have, let me draw this. We have something like this, which is our 5, 4, 3. So you have to know that this, smaller triangle here can help us get the angle and can also help us to calculate more. So let us draw this smaller angle outside so that we can get our angles, which is 5, which is 4, which is 3, then this. So for our cos theta will be equals to which is adjacent, which is 4 over hypotenuse 5. Then for our sine theta, which is equals to sine theta opposite over 3 over 5, opposite over hypotenuse. Then for our tan theta, which is equals to adjacent to so which will be opposite over adjacent. Our opposite is 3 over adjacent over 4. So you must know your SOHCAHTOA very well so that you don't forget these things. If you write your SOHCAHTOA at the top, you won't forget. So now, since we have our SOHCAHTOA here, we can find, okay, this, let me draw a line here so that our things can be proper. So now let's go to here. Since we have the triangle, let's find the horizontal and vertical components. So at C, our horizontal components equals to positive FAC, the cos of theta. Then vertical components equals to FAC, the sine of theta. So also, since we got this, that means we can find our angle, our theta. So it will be, let's use cos. Even if you use sine or tan to give you the same answer. Cos theta equals to 4 over 5. Theta equals to cos arc 4 over 5. Then theta equals to, so you use your calculator, you press your cos by 4 over 5, which will give you 36,87 degrees. So this is your angle. So now we are going to, since we calculated the vertical and horizontal components for each and triangle, we also have a vertical component which goes down, which is equals to our weight, which is, because it goes down, it will be 550 n. So here, so that you can all understand, here at our statement they said the crate has a weight of, let me highlight it for you, the crate has a weight of 550 n. So this 550 n is this here equals to, it is this here equals to 550 n, which goes down, which is our what, our vertical component. So now, since I've explained where our 550 comes from, let us continue calculating. So now we will say sum of the vertical components, which is our equals to 0. Then we will go back here Then find the vertical components. The first one is this one. So we go back. My negative FB. Okay. So it will be negative. Negative FAB, the cos of 30 degrees. Then we find another one, which is here, FA, the cos of theta, FAC, the cos of theta. So we will go this side and same. It is positive, so we will say plus FAC, the cos of theta equals to 0. This is our horizontal component. Then we make FAC the subject of the formula. So we will say, FAC, the cos of theta equals to FAB, the cos of 30 degrees. The cos of 30 degrees. And then we divide both sides by the cos of theta, so that our FAC can be the subject of the formula. So we will remain with FAC equals to FAB cos 30 over the cos of theta. So now we are going to our horizontal components. Okay, so we will say some vertical, so we are going to have vertical components. So we will say sum of the vertical component equals to 0. Then we go there and see our vertical components, which are, let me check. The first one, FAC, the sine of theta. Then FAB, the sine of 30. And so we'll start with FAB, the sine of 30 degrees, plus FAC, the sine of theta, minus 550. Minus 550 equals to 0. So FAB, the sine of 30 degrees, plus, since we found our FAC here, we substitute this where we see FAC. So it is FAB cos theta over FAB cos 30 over cos theta. Okay, so we will go back and say plus FAB cos 30 over the cos of theta equals to, so we take the negative 550 to the other side, which will be positive 550. So where we see the cos of theta, we replace it with let me go and check. We wrote it here somewhere. We said cos theta equals to, here we said cos theta equals to 4 over 5. Then where we see sin theta, we replace it with 3 over 5. So let's go back to our sorry, I made a mistake here. It's okay, this is not finished. FAC, we have a sin theta equals to 550. So we have FAB, the sine of 30 degrees, plus plus FAB, yo plus FAB, the cos of 30 degrees over, the cos is 4/5. Then we multiply it by sine theta is 3/5, which is equals to 550. Then we add this because they are like terms. So we'll be having FAB, we add them. So we'll be having 1,15 FAB equals to 550. We divide both sides by 550. We divide by 550. So not 550, sorry, my mistake. We divide by 1,15, then FAB will be equals to 550 divided by 1,15 will be equals to 478,261 newtons. So since we have our FAB, this means we can get our FAC. So where we see FAB, we substitute with the answer that we got. So FAC equals to FAB 478,261, the cos of 30 degrees over cos of theta is 4/5. So FAC equals to, we'll say 478,261, the cos of 30 divided by 4/5, which will give us 517,733 newtons. So we now found the forces that they were looking for. So now, since we found the forces that they were looking for, we have to draw let's draw our Cartesian plane first. So we'll be having our y-axis. Let me put this ruler straight. We'll be having our y-axis, then we'll be having our x-axis, we'll be having our x-axis, then we'll be having our triangle. So now our triangle will go like this. We'll be having something like, we'll be having something like this, then we'll have something like this, then we'll also have something like this that is going to join here. So now we have our angle of 30 here. We have our let me put it like this so that we have our angle of 30 here. We'll have our angle of 30 that was given here. So here we'll be having our angle of 30 degrees. Then our angle here will be determined by that, we said you can use sine, tan, or cos. So we'll be using cos because we know that cos theta equals to 4 over 5. 4 over 5. So theta equals to cos arc. Oh, sorry. We calculated the angle here. Let me show you. We calculated the angle somewhere. We calculated the angle, which is this one. Which we got cos arc of 4 over 5. Which is equals to 36,87 degrees. So now here we'll be putting our, let me write it here, 36,87 degrees. So this is this line. Okay, let me use another color. No, this line is our FAB, then this one is our FAD, then this one is our FAC. So this is our, okay, I forgot something very important. This is our y-axis and this is our x-axis. Then we are done with number 1. Let's go to number 2. Okay, now let's go to our second solution. Let me erase all of this so that we can do it. So now we'll be doing our second one. So for our second one, they say, okay, let me shift it this way. Okay, for our second one, they say the beam has a weight of 3.5 kilonewtons. Determine the shortest cable ABC that can be used to lift it if the maximum force cable can sustain ascent. So we'll start with the free body diagram. We have a weight, so our free body diagram will be like this. Okay, we have a weight going down, which is a weight which is equals to what? 3.5. So let me say weight equals to 3.5 kN. Kilonewtons means 10 to the power 3. Then we have a, okay, then we have a force again, a force of BC and ABF AB. Then we have FBC. So this is our free body diagram again. So now let's go here and do our diagrams. So now to calculate this very well, we'll make like, we'll draw a line here. Okay, let's draw a line here. So for the other side, we will draw a triangle. For this side, we'll use this. We'll draw this triangle. Then also on this side, we'll do the same thing. Right? So here is our B, and also here is our B. Then we have A here. So the distance here, we have 3, so divide 3 by 2 to get our 1, okay, 1,5 meters. Then we have our angle of theta here, theta unknown angle of theta, and also this side. Okay, let me make it like this so that you can all see. And also this side we have our, let me draw this triangle very well. So this side, okay, we have a triangle like this. Sorry, we have a triangle like this. Then we have our angle of our unknown angle of theta 1,5. Then this is our C. So now we need to calculate the shortest side, right? So to calculate the shortest side, we will start by finding the vertical components and the horizontal component. Let me make it smaller now so that you can see. So now our horizontal components this side will be equals to this will go this, they meet here at B, then this will go this side, then this one up, and also this one. Okay, so our horizontal components are negative T ft, let's say AF, okay, negative F AB, the cos of theta. Then vertical component equals to, going up, it will be T F, I mean AB, the sine of theta. We come this side, horizontal components equals to positive FAB, FAC, the cos of theta. Vertical components equals to FAC, the sine of theta. So we also have a weight. Again, that weight they give us here. So the weight is always going down. So our weight is going down, which will be negative. So we'll write it somewhere here within the color. Vertical equals to minus 3,5 times 10 to the power 3 newtons. So now we'll be saying sum of the horizontal sum of the horizontal components, which is equals to negative FAB, negative FAB, the cos of theta, plus FAC, the cos of theta. No, I made a mistake. Okay, EFRX, sum of the horizontal components equals to FAB, the cos of theta, plus FAC, the cos of theta, equals to 0. So since our FAB equals to our FAC equals to T, so where we see FAB and FAC, we will replace it with T. So so we will say minus T, the cos of theta, plus T, the cos of theta, equals to 0. So this and this I like 10, so negative positive is 0. So now we'll be coming to our vertical components. We'll say, okay, sum of the vertical components equals to 0. Our vertical components will be FAB, the sine of theta, plus FAB, the sine of theta, equal minus W equals to 0. Our W is our weight here. So now we will say, since we say F at B equals to FAB equals to FAC, so this is AC, FAC equals to tension, so it will be T the sine of theta plus T the sine of theta. All of these things, tension, equals to W. So 2T the sine of theta equals to W 3,5 times 10 to the power negative, to the power 3. So our T is our maximum tension, our maximum weight. So it will be 2 divided by 2T divided by 2T. Again, we'll be looking for our angle. So we'll be left with sine theta equals to 3,5 times 10 to the power 3 over 7,5 times 10 to the power 3, 2. Then our arc equals to, our theta equals to sine arc 3,5 times 10 to the power 3 over 2, 7,5 times 10 to the power 3. So our theta equals to, we'll say sine arc here, sine arc, then 3,5 times 10 to the power 3 over 2, 7,5 times 10 to the power 3. Our angle will be 13,493 degrees. So since we have our angle, since we have calculated our angle here, we will go back to our diagrams. So here we have we will use this one, this one. So we have our adjacent, then we don't have our hypotenuse, so we can use cos. So let us use cos. We'll be having cos theta equals to cos adjacent over hypotenuse equals to our adjacent over hypotenuse. So our theta equals to cos adjacent over hypotenuse. So our not theta, man, I made a mistake, sorry. Let me erase this. Okay. So our cos theta, we calculated the angle, which is 13,493 equals to, then our adjacent is this one, which is 1,5 over our hypotenuse, which is LAB. Then our LAB will be equals to, we will times this, then it gives us LAB cos 13, then we divide by the cos of it. So our LAB will be equals to 1,5 divided by the cos of 13,493. LAB equals to 1,5 over cos 13,493 equals to, our LAB will be equals to 1,543 meters. So since we have this, since we have the length of LAB, we are looking for the shortest length for L. So we will say LABC equals to 2LAB. So LABC equals to 21,543. This is 5, not 3. Then close our bracket. So our LAB will be equal to, we just say 2 times 1,543, which is equals to 3,086 meters. This is our longest side. So we will draw now we will draw a first polygon. Let us erase all of this. So now we will be drawing our first polygon. So we'll draw our partition plane first. Y-axis, x-axis, then we will have something like so we'll be having something like that. So this is our weight, then this is our FAB, then this is our FBC. Then here, sorry, I made a mistake here. Okay, this touches here. Okay, so this is our angle of theta. This line is FAB. This is our polygon. Then our scale is first of polygon scale is 1 centimeter equals to 1 kn. This is for our number 2. So now we are done with number 2. We are going to number 3. Now we'll be doing number 3. Okay, for number 3, okay, let's erase this. Okay, for number 3 they say, okay, in number 2, if the 5 kg block is suspended from the pool, the pool B and the sag of the cord is D equals to 0,15 m. Determine the force in cord ABC. Neglect the size of the pool. Okay, so now, okay, we are given the size of the block, which is this block, which is 5 kg. So now we will start by drawing our free body diagram. We will be having our, okay, okay, for the free body diagram again, we'll be having our weight going down, which is our weight. Then we'll be having our this one, which is FBC. Then we also have this one, which is FAB. So our weight equals to mg. We are given what? We are given the mass. So our weight will be equals to the mass that we are given, which is 5. Our g is constant, 9,81. So our weight will be equal to 5 multiplied by 9,81. Our weight will be equal to 49,05 m. Okay, now we have to draw our triangles, but let's just draw this thing, or let is it like this. Okay, then we have, this is half again, this is our 0,15, this is our 0,15. Then we have a, this all in all, it is this one, which is 0,4. So we will say 0,4 divided by 2, which will be 0,2 this side, 0,2 this side. So we'll have this and we'll have this. So now we'll be looking for this angle. So you can use cos or tan, but we'll be using tan since we have the opposite and the adjacent. So we will say tan theta equals to opposite over adjacent. So our tan theta equals to, our opposite is 0,15 over our adjacent is 0,2. So our theta, so theta equals to tan arc 0,15 over 0,215, this is 5. So our theta will be equals to tan arc 0,15 over 0,2, 36,87 degrees. We will say our vertical components. Our vertical components equals to 0. Then we go to our diagram here. We check our vertical components. So here it goes down. This goes down. Okay, let me use another. And we also have our weight. Our weight is going down, this weight. So now, okay, let me calculate it this side. We will say we will say EFY equals to 0. So we will be having, again we are looking for the tension, so tension at AB will be minus tension at AC equals to 0. Then tension AB equals to tension AC. Therefore we'll have 2t the sine of theta minus W equals to 0. 2t the sine of theta equals to W. 2t the sine of, since we have the angle which is 36,87 degrees equals to, we have the weight which is 49 here, 49,05. Then we divide by both sides by 2t the sine of 36. So we'll say divide by, not 2t, 2 sine 36,87 degrees over 2 sine 36,87 degrees. 87 2 sine 2 sine. So now we'll be left with tension equals to 49,05 divided by 2 the sine of 36,87. So our tension is 40,875 newtons. So now, since we have our tension, we can draw our first polygon. So for our first polygon, okay, let's use a ruler to draw our Cartesian plane. So we'll be having, our y-axis, then we will have our x-axis, then we name them y-axis and x-axis. Then we'll use the ruler again to draw. We have our weight here. We have our weight here, which goes like this. This is straight, must be straight. Okay, let me use another color. So this side, this is our weight. So, and also I made this too far. Okay, this side is our weight. Then we have our tension. If our tension goes that side, then we have another one which goes like this. So now here we have our force FAB, then this side is our FAC, then this side is our weight. Then we also have the angles that we got. So here we'll make it like this. We will say, okay, this will draw a line here. This angle and this angle are equal to, let me say theta. So our theta here is equals to 36,87 degrees. So this is our angle. This is then our scale is 1 centimeter equals to 10 newtons. So 1 centimeter equals to 10 newtons. So we are done with our number 3. Let's go to our number 4. Okay, now we are doing number 4. So let us erase these things for our number 3 so that we can do our number 4. So for our number 4, we have, okay, number 4, it says if the mass of cylinder C, which is this one, 40 kg, is 40 kg. Determine the mass of, so we are looking for this mass. Okay, we are looking for this mass. So here they say determine the mass of cylinder A in order to hold the assembly in the position shown. So now since we have this, we will start drawing our free body diagram. Our free body diagram will be like this. So I have, sorry, our free body diagram will be like, we'll have our F force tension at EA, tension EA. Okay, let me draw it properly. Our free body diagram will have tension EA, which is our weight. We'll have our weight here for EA. We'll have our weight. Then we'll have this force going there, which is EB, this one, which will be tension EB. Then we'll have another one going this side, which is our DE. Have this one going this side, which is this one, our TDE. So since we have our free body diagram here, okay, I want this diagram to show so that I can explain it very well. So now you have to know that this, let me change the color. This rope here, it is continuous. Again, so when it is continuous like this, it means tension at EB equals to tension at BC, which is equals to the weight of C. All of them on this rope are equals to the same tension. So since we have the weight, the mass of C, we can get the weight, which is the weight of C. So we'll say weight at C equals to mg. Then weight at C equals to, our mass is 49.81. Then WC equals to 40 times 9.81 equals to 392.4 newtons. So since we got our W here, we also know that the, okay, let me take it back like this. We also know that the, okay, we also know that the tension here equals to this weight. So tension at EA equals to weight at A. So we will go there and say, okay, sorry, we'll go there and say tension EA, we'll go there and say, okay, tension EA equals to what? WA. So now since we have this one here, we can find our tension at A. So now we will be saying so now we will be calculating. So now we will calculate, okay, let me go back to this diagram. we will check, we will be calculating using our E here. So at E, okay, let me write it properly this side. So at E, our horizontal components are 0. So we will be saying using our vertical components. Our vertical components equals to 0, right? So TEA, sorry, TEB, the sine of 30 degrees. We were given an angle here. Okay, here we have an angle, this angle. We have this angle, so we are using E. So at E, some of the horizontal components again are okay. Let me try. At E, some of the horizontal components, TEB, the sine of 30, minus TEA equals to 0. So EB, we say EB equals to BC equals to, so it will be 392,4, the sine of 30 degrees minus TEA equals to 0. So we will have 392,4, the sine of 30 degrees equals to TEA. So now, therefore, our TEA equals to 392,4, the sine of 30 degrees, which is 196,2 N. So here we said TEA equals to WA. So WA equals to mg. Where we see WA, we replace it with what? With TA. So since we got our T, we will say since we got our, we will say TA equals to mg. Since we got our TA here, we'll say 196,2 equals to, our mass is unknown, 9,81. We divide it by 9,81. We divide 9,81 so that we can do what? We can make M the subject of the formula. So now therefore our M will be equal to, we'll say 196,2. We divide it by 9,81. So our answer will be 20 kilograms. So this is MA. This 20, which is equals to W, weight at A, because weight at A equals to what? TA. So, and we calculated using the TA. So now we go here, we go back. So our answer here is, the weight that was needed here is 20 kg. So now let us draw our polygon diagram. Okay, let's make it like this. For our number 4, we'll be having, okay, let's do our number 3 again using our vector diagram. Okay, number 3. Number 3, we will say, we'll draw our free body diagram. Our free body diagram for number 3 will be like this. We'll be having our weight going down, weight for A, then we'll be having our tension for BE, then we'll be having our, no, sorry, it is not going up. Then we'll be having our tension force for TDE, and also we'll be having for another weight for that, for this side we'll be having our weight for C, weight at C, weight at A. Then we'll be having our tension force for BC. So now, since we have drawn our free body diagram, now let us try and calculate them. So now, okay, we know that since from here it goes like this means the tension at TEB equals to the tension at TBC, which is equals to WC. Do you understand me? So our WC equals to mg, since we have the mass at C. So WC equals to M49.81. Then our W at C equals to 40 times 9.81 equals to 392.4. So now, and also our F tension at EA, first tension at EA equals to WA. This one, sorry, this one equals to this weight. So now we will draw a vector diagram, something like that, so that we can see where we are going. Let me use another color. Let me use red for danger. So now this side will be having something like this, right? So now this side will be having first tension at first tension or tension, same thing. Okay, tension at EA, which is this going down. Then this side will have first tension at D, then we'll have tension EB, then this will be our 30 degrees. So since we have this, we will say tension EA equals to tension EB, the sine of 30 degrees. So tension EA equals to, since we got EB here, which will be 392.4, the sine of 30 degrees. So now we will say, okay, we'll say 392.4, the sine of theta. We will have TEA equals to 196 comma what, comma 2 newtons. Then since we have this, since we say TEA equals to W at M, so we will continue by saying WA equals to mg. So this means here we'll say TEA equals to mg. Our TEA is 196.2. M, we don't have it, G is constant 9.81 divided by 9.81 divided by 9.81. Then our mass will be equal to, I'll say 196.2 divided by 9.81, which will give us 20 kg. Then that's our final answer. We are done with this one. So now let's do our number 5. Let's erase this and start with our number 5. Okay, sorry. Okay, and now let's do number 5. For our number 5, they say determine the tension in cables AB, BC, and CD necessary to support the 10 kg and the 15 kg traffic light at B and C respectively. Also find the angle of theta. So now for our number 3, we will firstly draw our free body diagram for B. So for B, free body diagram, our free body diagram will be like this. It's our weight going down, then we'll have our force BC, then we will also have our force, let me say tension, so we'll have our TBC and our TAB. Then let me use another. This side will be having our, here we have our angle of here theta. This side our theta is, they give us 15 degrees. This side for B. So we will start calculating using our B side. Now, since I have drawn, our free body diagram will be like this. Okay, let me use another color. Our free body diagram for B, it will be like this. Go down, then this side, then this side, AB, then BC, then our weight at what? At B. So now let's calculate order for this side. So now, let's draw our tension for our free body diagram for C. So let me say line here. Okay, for C, our free body diagram will be like this, then like this, and like this. Then this will be our TBC. Then this will be our WHC. This will be our TCD. So also this side we have, okay, let me use another color. So this side we also have, will be having, I get it, this is our free body. I don't want to ruin our free body. Then we have something like this, then here we have theta, which is unknown. Then I say TBC, WC, CD. So now let's calculate this side. Okay, so now our we'll say our horizontal components must be equal to 0. Then FBC minus tension at BC minus tension BC minus tension AB equals to 0. So tension BC minus tension AB will be the AB, the cos of 30 degrees, 15 degrees. So they give us the theta 15 degrees. So we are done with this one. This is our equation 1. No, equals to 0. Then TBC equals to TAB, the cos of 15 degrees. This is our first equation. Then after this we go to our vertical components for this side. Okay, EFY equals to 0. Then for this side we'll be saving TAAB, the sine of 15 degrees minus WB equals to 0. The FAB, the sine of 15 degrees equals to WB. So remember, FAB, the sine of 15 degrees equals to, remember here on the statement, they said necessary to support the 10 kg and the 15. So the 10 kg is for B, is for weight B, and the 15, so we have the mass, we don't have the weight. So since we have the mass, we can calculate what? When you have the mass, you can calculate the weight. So it will be 10 multiplied by 9,81. So tension, not force. Why am I saying F? TAB will be equals to 10 times 9,81 all divided by sine 15. Tension at AB will be equal to, we'll say 10 multiplied by 9,81 divided by sine 15. So this side will be giving 379 379,03 newtons. So we will go back and write it here. Okay, let me write it here. Say TAB equals to 379,03 newtons. So now we are going to our next. We will go to, since we have the tension at since we have this, we can substitute it here on our equation 1. So when we substitute it, we can substitute it on our equation 1, which is TBC equals to, okay, which is this one, TBC equals to TAB, the cos of 15. So where we see AB, we'll substitute TAB, the cos of 15 degrees. So TBC will be equals to 379, the cos of what? The cos of 15 degrees. This is 5. TBC will be equals to 379, 03. 379,03, the cos of 15. 379,03, the cos of 15 degrees, which will be equals to 366,115 newtons. TBC. So we'll go up there and write our TBC. So TBC equals to 366,115 N. So now we are going this side for so now we are going this side. So I'll use the other color so that we can see, or this is for B and this is for C. Okay, now we are coming this side. This side we will start with the sum of the horizontal forces. So we'll say sum of the horizontal forces are equals to 0. FCD minus FBC equals to 0. This color I think is not that visible. Okay, we'll say sum of the horizontal forces are equals to 0. CD here, horizontal goes this side, it will be positive, minus FBC. Let me use another color. This color is not that visible. So here we will say sum of the horizontal forces. Sum of the horizontal forces are equals to 0. Then we will say tension at CD minus tension BC equals to 0. This one is negative, then this one is positive. This one is for TCD. So TCD, then it will be TCD, the cos of theta, this angle, minus TBC equals to 0. So we have BC, we wrote it there. Here is it, which is 366,115. So we will substitute it. We will say TCD, the cos of theta equals to TBC. Then TCD, the cos of theta equals to 366,115 N. Equation 2. Then we look for the vertical component. Sum of the vertical components equals to 0. FCD minus WC equals to 0. FCD, the sine of theta equals to WC. So remember here they told us the weight for C. They told us the weight for C, which is 15. So, no, not the weight, the mass. Since we have the mass, we can find the weight. And also, let me show you here. Our TD, it is this one going up, it's positive. then our WC, it's negative, it's this one. So now, okay, let me go and finish up what I've started. So now we know that our FCD, the sine of theta, equals to 15 multiplied by multiply by 9,81. So FCD, not F, so I made a mistake. Tension at CD. For our vertical components, TCD, the sine of theta minus W, equals to 0. TCD, the sine of theta, equals to W. So when we go back, we can see that they gave us the weight for here, the mass for here, which is 15. They gave us the mass for here, which is 15. Then also we go to that other free body diagram we have from that side. This is our WC, weight at C, which goes down, which is negative. Then going up, this is our TCD, the sine of theta, this angle that we don't know. So now we'll go back and continue with what we have studied. So now, since we know that our TCD, the sine of theta, equals to, since we know that our mass is 15, our weight is mass multiplied by G. Our G is always constant. TCD, the sine of theta, equals to, then we say 15 times 9,81, which is 147,15 N, equation 3. So now we will divide equation 2 and equation 3, since we have T. So now we will say, let me write with the black one. We will say, okay, we will say equation 3 divided by equation 2. So after this, we will be saying our equation 3 is TCD, the sine of theta, equals to 147,155. Then we go to equation 2, which is TCD, the cos of theta, okay, divided by TCD, the cos of theta, 366, what? 366, 115, okay. 115. So now this will cancel this, then sine over cos is tan, then tan of theta equals to 147,15 over 366,115. So when it is like this, we'll find our theta. Theta equals to tan arc 147,15 over 366,115. Then theta equals to tan arc 147,15 divided by 366,115, which our angle will be 21,9 degrees. Then after getting your angle, you can say to find your TCD, you'll say TCD, the sine of theta equals to, we use the equation 3. Where is it? TCD, the sine 147,15, then divided by sine theta divided by sine theta. Then our TCD equals to 147,15 over sine, our theta is 21,9 degrees. Then TCD equals to 147,15 over sine 21,9, 394,517. So we will go back there and write our answer for the angle N. So we come back here, we use the red one, then we will say TCD equals to, so TCD equals to 394,517, and then our theta equals to 21,9. Then we are done for today. Thank you very much.